I try to imagine a fellow smarter than myself, and then I try to think, what would he do?
Charge up your axons, ready your receptors, and shift your lobes into upper beta phase. You are listening to Smart Drug Smarts, the podcast dedicated to helping you optimize your brain with the latest breakthroughs in neuroscience, nootropics, and psychopharmacology.
Hello and welcome to Smart Drug Smarts. I am your host, Jesse Lawler, excited to bring you the 106th episode of this podcast, dedicated to the ongoing improvement of your brain by any and all means at your disposal. This week, we're going to go off into the weeds. This is not an episode specifically about how to improve any aspect of your brain, but it's kind of some interesting brain trivia. It's something that you've probably heard about, may know something about, but probably do not know as much about as our world-leading guest, Dr. Richard E. Cytowic, who's going to be talking with us about the subject of synesthesia. Synesthesia is this interesting ability to jointly perceive a signal that comes in on one perceptual path on multiple perceptual paths. So, for example, a certain sound might make you see a certain color pattern. Things like that. We'll be talking all about that in the main interview, but a really interesting cross-wiring of some areas in the human brain. If you hang around until the very end of the episode, well, it's the holidays as we record this. It's December 11th this episode will be published on, which means we're right in the middle of U.S. holiday season. A lot of us are seeing family. Everybody is almost required to be jolly. There's Christmas music playing in all public places. And so just to be contrary, in the Ruthless Listener Retention gimmick, I've got something special for all the grumps out there. If you're feeling grumpy and you want some help with your grumpiness, justification, rationalization, I've got something special for you. So hang around until the end of the episode. But as usual, let's kick things off with This Week in Neuroscience.
Smart Drug Smarts, This Week in Neuroscience.
So one of the things that I've felt repeatedly over the course of doing this podcast and talking with people about all these interesting and sometimes bizarre things that the human brain can do is I felt a lot of jealousy towards people that have interesting brain conditions. Just out of curiosity, I would love to drop into the brain of somebody like a synesthete that we're going to be talking about in our main interview and see what that's like for a while. Similarly, I've always been curious about out-of-body experiences. I've never had one myself. It seems incredibly hard to imagine what that would even feel like. But it's not a terribly uncommon thing, and apparently scientists at Sweden's Karolinska Institute have not only created a surefire way to create a feeling of being out of your own body, but they've also done so in an experiment that is shedding light on how people come to feel like they are in a physical position to begin with. If you're like me, if you have never had an out-of-body experience, it might kind of seem intuitively obvious. Well, of course it should feel like we're in our head. We triangulate binocular vision and the sounds coming in from our ears, and how could it feel like we're anyplace else? But apparently that's not the case. And there are actually specific brain regions that actively work to make us feel like we are in a physical location despite the information coming in from our senses. So way back in 2014, a Nobel Prize in Physiology and Medicine went to the scientists who discovered what are now called place cells that exist within the brains of rats, people, and other vertebrates and trigger feelings of recognition when we're in places that we've been before. So sort of a neurological correlate for a physical map of our environment. However, it was not known whether these place cells had anything to do with the feeling of being in a place, of actually having kind of the perceptual sense that, yep, here I am, rather than recognizing the place itself in a more abstract way, like here's the place on a map. So the participants were wearing head-mounted displays, so imagine something like an Oculus Rift, where they're seeing a visual display that has the body of a stranger in the foreground. They can see their own physical body in the background, but their own head is covered up, so they don't see their own face, and instead what they do see is this body in the foreground that's not theirs starts getting physically touched on the same body parts at the same time as their own body is touched. And apparently, in just a matter of seconds, the brain merges the sensation of the touch that they're receiving on their real body with the visual input of this closer appearing stranger's body that's being touched in parallel places at parallel times, and very quickly the person gets the illusion that the stranger's body is their own body, and that they're actually located in the stranger's position in the room. What's really striking about this is that they were 15 for 15 on the research subjects, and that it happens very fast. And this is without any drugs, without any electrical stimulation to any areas of the brain. It's just a pure perceptual illusion. As the scientists got the hang of creating this illusion, they could essentially sort of teleport the person around the room, at least as far as the subject was concerned, and put them in different places. And while they were doing this, they were scanning the person's brain activity, and they could see that the perceived self-location of the subject could be decoded from specific activity patterns inside the temporal and parietal lobes of the brain. And this wasn't an all-or-nothing thing. They could show a systematic relationship between the perceived vividness of the illusion, how convincing it really felt, and the brain activity in these regions. Last but not least, and most relevant to the the 2014 findings about these place cells was that the hippocampus, the area where these place cells had been identified, was one of the regions where the subject's perceived self-location could be decoded from. Said the principal investigator, Henrik Ersson. This finding is particularly interesting because it indicates that place cells are not only involved in navigation and memory encoding, but are also important for generating the conscious experience of one's body in space.
We like to think of ourselves as a digital speakeasy for brain hackers, but you can call us Smart Drug Smarts.
Happy to report that we picked up a 5-star review on iTunes this week from somebody by the name of Windshield Wiper Hands, who says, I approached this podcast skeptically, partly because I work for a big-time podcast producer and don't often venture outside of their content. But I have an active interest in drugs, philosophy, and human enhancement, so I gave it a try. The credentials of the guests really impressed me, and the host interviews well. He deals with specialized information and super educated people, and yet manages to keep listeners engaged with his questions. Well, thank you so very, very much. Also had a very busy week on the email. I'm not sure if a lot of emails flying back and forth as people get ready to take time off for the holidays, but for one reason or another, it was an effort to touch inbox zero this week. I got one email that I wanted to share from someone who's a first-time purchaser of Nexus, our cognitive stack, who said, Hey Jesse, here's another amateur review. I started using Nexus recently, and it is superb. I've used aniracetam before on its own, and I get the feeling that the quality of that was nowhere near as good as this. I got consistent focus for at least 4 hours while on it, noticeable boost in creative thinking, and it's excellent at reducing my social anxiety. I foresee myself using Nexus on a daily basis, and mitogen like twice a week. Mitogen, you may remember, is our other supplement stack, aimed specifically at your mitochondria. Both of those are available on the web over at axonlabs.io, and we still have a 15% across-the-board sale going on now through Christmas, so you got a couple more weeks to pick that up and do a little something for your brain and body in advance of 2016, or maybe grab yourself a subscription. We do offer ongoing subscriptions over there, and keep yourself loaded up for 2016 and beyond. We've got a weekly newsletter for Smart Drug Smarts called The Brain Breakfast, and if you're not already signed up to be a part of that list, I would cordially invite you to do so. We've got a sign-up link over at smartdrugsmarts.com/newsletter, and that we try to keep a little bit of a cognitive smorgasbord. It's generally a bit of a micro article, a reminder of the things that we've got going on the podcast, some pointers to things that might be on the website, and certainly information around the web on the goings-on in neuroscience. And I'm also going to start putting some reading recommendations in there. I do a lot of reading. Some of it's related to the podcast and the types of topics that we talk about here. Some of it's just other stuff that I find cool. It's almost all nonfiction, so if you're a fiction person, I'm probably not going to have much for you. But if you're looking for the occasional cool book recommendation, that's just one more reason to sign up for the Brain Breakfast. We're not going to clutter up your inbox. It's just once a week, low annoyance, high impact, and that is at smartdrugsmarts.com/newsletter.
Smart Drug Smarts.
So I remember being a kid in middle school and talking with some friends about the boundaries of the universe, thinking like, okay, what's at the very edge of the universe? But then if you go out a little bit beyond that, then what's there? It's like there wouldn't be a wall, and just boggling at that concept of infinity, just going, whoa, as like an 11 or 12-year-old. And I felt the same thing when I first heard of the idea of synesthesia, that our seemingly fixed, very defined senses, our sight, touch, sound, etc., can sometimes get commingled. And in fact, that some people live with this being their normal experience of dealing with reality all the time. That's always been a fascinating topic to me. I admit to being more than a little jealous of these people, and although this doesn't really have any brain hacks associated with it, I was kind of hoping that there might be something directly actionable that would come out of this interview. I'm not sure that that will be the case, but if having a really interesting topic that makes you say, whoa, is enough of a motive, then I very much encourage you to keep listening. We're going to be talking with Dr. Richard E. Cytowic, who is a medical doctor and author, and one of the world's leading authorities on synesthesia. He's the author of The Man Who Tasted Shapes, and co-author of Wednesday is Indigo Blue, both of those dealing with synesthesia, and we're going to be talking with him about all aspects of this really interesting neurological condition. So with no further ado, Dr. Richard E. Cytowic.
Well, everybody knows the word anesthesia, which means no sensation. Synesthesia means joined or coupled sensation. And there are children born who have 2, 3, or all 5 of their senses hooked together, such that my voice, for example, is not only something that they hear, but something that they might also smell or taste or feel as a physical touch. Typically, they're shocked at a young age to discover that other people aren't like them. And it runs strongly in families, and that's the exception, of course, when your parents know what you're talking about when you're drawing different kinds of sounds, for example. And either people think it assumes that everybody does it until they make some innocuous comment and get a weird reaction, or they assume that they're the only person in the world. There's one of my earliest research subjects said that when she was young, she told her best friend that the letter A was the most beautiful color she'd ever seen. "What does your A look like?" she asked. and the girl turned and said, "You're weird," and they never talked about it again.
Is there any commonality between what one person's A would look like versus another?
Well, that was the problem in the 19th century when synesthesia was incredibly popular, is that the couplings appear to be idiosyncratic, so that the alphabets are not similar at all. However, we being David Eagleman and I, have studied 7,000 alphabets, synesthetic alphabets, and there are commonalities among them. So, for example, that O tends to be white, Z tends to be black, I tends to be gray. But when you ask non-synesthetes to just sort of imagine that they can do this, you find trends as well in non-synesthetic alphabets. So A tends to be red, B tends to be blue, etc. You can actually plot a color space. Let's say if Fred has a certain color, then what does Mary have when she's over here? And basically you can draw a straight line through them and show that there are trends among both synesthetes and non-synesthetes. Now, this does not mean that synesthesia is a mere exaggeration of normal traits, but it means that synesthesia is a porthole, a window onto how the brain perceives and remembers.
Now, you mentioned that this is something that appears from birth. Is that always the case? Is it always there from the start and there for a person's entire life?
The answer is mostly. The 99% of synesthetes say that they've always had it. They can't remember not ever having it. And one woman wrote me and she said, I'm now almost 90 years old and the colors are just as bright as they ever were. Now, having said that, of course, in science, there are exceptions, and some people will not really realize that they have it until around the age of puberty. Also around that age, they may then lose it. So I have two twins, and one brother said, I used to do this, but after my brother's bar mitzvah, it seemed to go away. And of course, puberty, as everybody knows, is a time of enormous change. The body is undergoing tremendous change, and of course, the brain is part of the body, and it's going a huge reorganization around the time of adolescence, and where all these hormonal influences are basically resculpting synapses and pathways. So it is possible then to lose it.
And what percent of the population do we think experiences some level of synesthesia?
4% of the population. But the gene is, even though it's strongly hereditary, that is, it runs strongly in families, so that you'll see it in multiple generations, the gene does not have a full expression, what we call penetrance. So in terms of overt synesthesia, 1 in 90 people, so basically 1 in 23 people inherits the gene or genes, and 1 in 90 then has some kind of overt synesthesia. Now, if you have, the most common are the days of the week are colored. Next would be colored alphabets and numbers, called grapheme synesthesia. Grapheme being the written elements of language, A, B, C, D, 1, 2, 3, 4, punctuation marks, etc. And this holds both for Roman alphabets and non-Roman ones like Greek, Hebrew, Japanese, Chinese, Arabic, etc. It doesn't matter. It's the visual appearance of the grapheme that then triggers the color. So having said that, if you have one kind of synesthesia, you have a 50% chance of having a second, third, or fourth kind.
We have the 5 primary senses that everybody thinks about. Then there's sort of these lesser senses that you don't think about so much, like your sense of balance or your kinesthetic sense of where your limbs are in space. Do these ones ever get cross-wired into synesthesia as well?
There was a famous young adolescent, when he heard certain words, and including nonsense words, he would assume a certain posture, like a statue. So there would be this bodily sense of movement and of posture. And the physician who tested him, made sketches of all these postures to both normal words and nonsense words. And then 5 years later, he retested him and found that he gave exactly the same kind of poses to this. So those are really sort of very, very rare, as was, for example, the first synesthete that I ever encountered, Michael Watson, who is the man who tasted shapes of that book's title. And for Michael, taste and flavor he felt not only in his mouth, but also in his face and in his hands. The irony is that, years later, when I started collecting much, much larger numbers of subjects, synesthetes, it turns out that taste accounts for only 1% of all synesthesias. So it was rather ironic that the rarest kind was the first kind that I studied.
How did you get into the study of this? What led you down this path?
Oh, complete accident. I love words. And when I was a resident in neurology, I would escape from the page operator and the beeper by going to the sub-basement of the library because the signal didn't reach there. And I would have like 5, 10 minutes of peace. And I would browse all the old books. And one of the books I came across was a book by Alexander Luria, who is one of the founders of neuropsychology. And his book was The Mind of a Mnemonist, or the memory expert. And he described this guy that had a limitless memory thanks to a five-fold synesthesia. So he had all these extra hooks that he could hang things on, and he went on to become a stage performer as, Mr. Memory. Well, I thought, oh, what a great word, anesthesia, synesthesia, and I filed it in the back of my mind. And then I was in North Carolina at the time, living next to the School of the Arts, and I had a new neighbor who taught lighting design there. And he invited me to dinner to meet some friends and all that, and then said, oh, it will be a few more minutes. There aren't enough points on the chicken. And his friends laughed and said, oh, Michael, what are you smoking now? But the host turned to me and said, and he was beet red, embarrassed he had blurted this out. And he said, well, you're a neurologist. Maybe you understand. With an intense flavor, feeling sweeps down my arm, and I feel weight, shape, texture, and temperature as if I'm actually grasping something. And I was just trying to be polite. And I said, oh, you have synesthesia. And his jaw dropped and he said, you mean there's a name for what I do? And that took it off. I happened to be in the right place and right time and had to have enough mentors and equipment to study him in depth. Now, people have asked me that question for 8 decades, and I've always given that answer. And it really wasn't until recently, until something else dawned on me, which was that, I'm gay. And as a 10-year-old in New Jersey, my father's medical profession said that I was sick. Would be 1962. The state said that I was a criminal, and the church said that I was immoral and going to hell. And I hadn't done anything. So it's like these people don't know what they're talking about. They don't know me. So the notion that something wasn't supposed to be, see, I wasn't supposed to feel the way I felt. And the same thing applies then to synesthetes, that everybody knows that there's 5 senses that travel along separate channels, and that the days of the week in the alphabets don't have colors, and you can't see music. You're making this up. You're crazy. You're an old pothead. You just want attention. That is the typical response of orthodoxy to something that either can't or won't understand. It denies it and tries to explain it away. And, the first 15 years of my research, it was basically confronting these people who said, this is really so weird. In fact, early on, when I told my colleagues about Michael Watson, they said, oh, stay away from this. This is too weird, new age. It'll ruin your career. So, that just shows you the mindset of the establishment. Whereas I was so taken with these people, and they all had the same story. It didn't matter what kind of synesthesia they had, but they were basically telling me the same story over and over and over. And I said, there's got to be something here. And so the question isn't, we can't find anything, therefore there's nothing wrong with you. It's like, we're not looking at it in the right way. So we need to rethink stuff. So the fact that the early critics say, well, this is counter our models of how the senses work, I said, well, maybe our models are wrong because they can't account for synesthesia. And of course, that turned out to be the case. The reigning model at the time called modularity, that is language, vision, all the senses were in separate modules, both physically in the brain and psychologically in the way they worked, and by definition, they couldn't combine. Well, that went down the drain, and so now people are realizing that instead of being just an odd curiosity, synesthesia is in fact fundamentally important to understanding how the brain is organized and how we perceive. So it feels really good to have caused a paradigm shift.
That's fascinating. And what do we know about the underlying biological mechanism of what's going on here, of why these senses are getting cross-pollinated?
Well, we have gone through a number of theories, and, as good scientists, every time you get more information, you have to revise your theories. So I won't go through the litany of what's going on. One of the more interesting ones was synaptic pruning. All newborns are making neurons furiously at the center of the brain at the rate of 2 million synapses per second. That's astonishing.
Wow.
And then as the kid grows up and starts to crawl and put everything in his mouth and is undergoing a visual and sensory apprenticeship with the world, exploring, these synapses then get pruned It's sort of a use it or lose it, and the brain is being sculpted. And so things settle down around, I don't know, 5, 6 years of age. And then there's another rearrangement going on during puberty. And of course, the brain isn't actually finished maturing until about age 25, which is why teenagers have all the drive but none of the judgment, and why you don't want to give them your car keys, particularly if they're going to be riding with friends. But that synaptic pruning, or the failure to prune, which would then explain synesthesia, that you have these early pathways still retained in some people, that didn't account for the acquired synesthesias or the epileptic synesthesias and other varieties. And there are 5 research groups around the world hunting down the gene or the genes, and we've found a number of markers and all that. So synesthesia, you inherit this propensity to cross-connect different, not only just senses, but different aspects of cognition. But here's the thing, that genetically inherited biological propensity has to be then somehow coupled with cultural artifacts such as alphabets, letters, the names of the food you eat, how to tell time, etc. And this is true in all languages, and we don't know how that happens yet. But there are people setting up very, very ingenious and very, very difficult experiments with newborns and young children to sort of tease out how this coupling comes about and why it stays so permanent. All right, so you have a brain that's forming and making all these connections and stuff, and you have this gene that's a gene for hyperconnectivity. So when it is expressed in sensory areas of the brain, then you have an overt synesthete. They hear music, they taste shapes, they taste words, etc. Now here's the question. If 1 in 23 people are inheriting this gene, which if you ask people, what good is it? They tell you, well, it helps remember, but other than that, it's just sort of a pretty thing. Why is evolution selecting for this gene so strongly to keep it so frequent in the population? We believe that this gene for hyperconnectivity underlies the basis of metaphor, or seeing the similar in the dissimilar. So if this gene is then expressed not in sensory parts of the area in the brain, but in, let's say, executive parts or motor parts or parts related to memory, then what do you get? What kind of person do you get from that? And we think because synesthesia is overrepresented in artists such as writers, composers, sculptors, etc., painters, that this in fact makes us smarter as the human race as a whole.
That's a really interesting question. So you mentioned that it's conserved within the population. It's something which isn't detrimental because it hasn't been bred away. How come it hasn't taken over? How come we're not all synesthetic?
Well, we are, actually, and it's easy to show that. Synesthesia, like, for example, meditators, there's 3 groups of meditators: beginners, people who are fairly practiced at it, and then really adepts or even teachers. And the more time you have, experience you have meditating, the more likely it is to experience synesthesia during the meditative state, which is actually shutting off the cortex, the thinking, rational, judging part of the brain, and just letting the rest of it be. You can also have synesthesia during sensory deprivation, everything from the tranquility tank, the flotation tank, to things like losing vision, losing the ability to feel, etc., which can either happen in old age or as a result of some kind of injury. Perhaps the coolest demonstration that we're all synesthetic is an experiment that an Italian colleague did. He blindfolded volunteers for 48 hours, after which the primary part of the visual cortex all of a sudden responded to touch, sound, and spoken words. Now, if you removed the blindfold for just 12 hours, then V1 reverted back to responding only to visual input. So 12 hours is, of course, way too short a time for new synapses to grow. So what we conclude is that these connections from other senses must have already been there, but were unused as long as vision was inputting a signal. See, the visual input then kept all the other connections quiet or below the threshold of awareness. And that makes sense because the majority of what we do, what our brain is doing, must be unconscious. Consciousness is just this teeny tiny tip of the iceberg.
Yeah, a little flashlight on a whole lot of information going on.
Yeah, it's like the chief executive of a corporation can't possibly know what its 300,000 employees are doing. It only gets called in when there's big decisions to be made. And that's the way consciousness is. If we were conscious of everything, we would run out of energy. In fact, there's a cute little TED Ed lesson I have called "What Percentage of Your Brain Do You Use?" You can just Google that. Why is this 10% myth absurd?
Yeah, that's one of those things that just won't die, unfortunately. It's out there in culture as a meme, but it's so silly when you think about it.
But it deals with consciousness and why attention, for example, is shifting from this to that, as the way people do with their smartphones and all that, why that consumes so much of the bandwidth that we have available to us. So mental fatigue is not just a trope, it's a real thing. Our neurons get tired.
Is synesthesia equally prevalent among all human cultures to the extent that we know about? I mean, does it seem like that 4% number is something that holds?
In all populations that have been studied around the world, yes, everything is similar. And the ratio of men to women is 1 to 1. At first, we didn't think it was because we were getting ratios of 3 to 1, 6 to 1, then 9 to 1. And I thought, gee, maybe it's just because men don't want to talk about unusual experiences. So 2 colleagues of mine, one from Edinburgh, one from London, did a lovely experiment at the London Science Museum in Kensington, where they took, this was sort of a random population, and say, do your letters and numbers have color? And if they did, they sat up in front of a computer, which showed basically the Windows color picker of 16.4 million colors. They would have to pick as alphabets and characters rolled through. And that way they were able to sort of verify who had synesthesia and who didn't. And also that they finally discovered that the sex ratio was 1 to 1, men to women, and that indeed men had not wanted to talk about having unusual experiences. I guess that feeds into a stereotype, doesn't it, of unemotional men?
Yeah, I mean, to me it sounds more like a superpower than like a detrimental thing.
I think maybe if you frame it that way, more people would be willing to come out of the closet. But that doesn't seem to be a big problem now these days. I mean, I've been doing this for 30, 35 years. I'm always impressed how just people in all walks of life, all levels of education and grades, they've heard of it, they've read books about it, they've written book reports about it. So it's really finally entered the vocabulary and the general consciousness.
For somebody that doesn't have synesthesia, or at least has never crossed that perceptual threshold, short of blindfolding yourself for 48 hours or jumping into a flotation tank, are there any other ways of inducing it?
Well, again, as I said, meditation is one way. But again, that takes a lot of effort. And I think most people aren't willing to put in the practice that it takes to become still, find the still point within oneself. And then the chances of having synesthesia aren't all that high. The other, of course, would be to take LSD or mushrooms, but that synesthesia is not quite like the naturally occurring kind. At least that's what the synesthetes who have taken LSD in the past say. It isn't quite the same. But then, of course, those kind of hallucinogens, which are anti-serotonergic agents, only produce synesthesia in about 9% of ingestion. So again, it's like, do you really want to screw your brain up in order to experience this? And of course, I can hit you in the head with a hammer or throw you off the roof, because head trauma also causes synesthesia. One of my books I wrote is about closed head trauma, and those patients in particular, light and sound would produce these shooting pains in their extremities. That was temporary, though. If they had a closed head trauma with a concussion, then that lasted about 3-4 months and eventually faded away.
Yeah, doesn't sound very pleasant.
I think instead of trying to experience what it's like, I think you should really look at the root lesson of all this, which is that every brain has a uniquely subjective point of view, and yours is different. And so I think what understanding synesthesia is that here are these people with a slight gene mutation, perhaps in even just one nucleotide, completely changes the way they see the world. Now, are you going to insist that they see things like you do, which is what political brawls are all about? Or are you going to accept that, everybody has a different point of view, and it's up to us, to you, to try to put yourself in somebody else's shoes and see things from their perspective? Famously, eyewitnesses of accidents and plane crashes and all that, they tell different stories, even though they saw the same, quote, objective events. Well, they're not objective. There's no such thing as objectivity. We're subjective through and through.
That's a great point. The brain is sort of a big perceptual filter for everything. It's just one of those ideas that I think it's so important to continually re-hit.
Yeah, I mean, we're bombarded by what's physicists called flux. So this energy hitting us from the sun, the cosmos, visible and invisible light, and we're only sensitive to a bunch of it. And then overlaid on the natural flux is the man-made stuff. Our Wi-Fi, our radio, our TV, communications, submarine sonars. We're in this soup of energy. So the brain has got to be an incredible filter to just respond to certain amounts of that. But at the same time, it has to be highly sensitive. So there's a real paradox there of how we all get our unique point of view.
Smart Drug Smarts.
So I always listen to these interviews after we record them and edit them, and sometimes something just jumps out at me as, oh my gosh, Jesse, why did you not ask that? And I've got one of these for this interview. I'm not even sure how they would test this, so I suspect that the answer will probably be we just don't know. But I sure would be interested to know whether synesthesia occurs within animals and to what extent that it does. That 4% figure that was tossed around as to the prevalence of synesthesia in the human population, I find myself wondering why that is. Clearly, it doesn't seem to be a dangerous or a maladaptive trait that would be bred out of the population, and yet it's also just sort of hovering at this fairly low level within the population. It hasn't been ballooning, and I would think definitely if we find that it's something that exists among animals too, heritable synesthesia has been around in human populations for presumably a very, very long time. So the question becomes, how come it isn't any more common than it is? Why is it sort of hovering at this 4% level and not either dying out or taking over the whole population? I have no idea what the answer is, but I find that to be a really interesting and kind of thought-provoking question. And it might just be the boring answer. It might be that it kind of doesn't matter. It's like the color of a person's eyes. It's just not so much of a selective factor that it's going to tip your survivability one way or the other. But maybe there's something more to it than that. If anybody's got any wild theories, I'm all ears or all eyes or whatever. If you want to email me at jesse@smartdrugsmarts.com, I would love to read your theories. But now let's move on to the ruthless listener retention gimmick.
Smart Drug Smarts, ruthless listener retention gimmick.
So it's the holidays. It's a time to be cheery and merry and be giving gifts and hanging out with in-laws and pretending that you're not annoyed by other people's screaming kids at holiday get-togethers and things like that. And sometimes, let's face it, this can be a little bit annoying. And maybe if you're a little bit of an introvert or you're just not somebody that's constantly doing belly laughs and stuff like that, you might feel a little bit resentful of some of this forced joviality sometimes. And it seems like in recent years there's been a lot of science supporting the idea that stress is a killer and happiness is not only more fun, it's actually good for you in a physical sort of way. Which means if you're not on the ridiculously buoyant end of the happiness spectrum, you might almost kind of feel like the world's picking on you a bit. But I've got some good news for you. According to a very, very, very large new study published in The Lancet, which is a major medical publication, this is a study based on over 720,000 women. It turns out that happiness, into and of itself, has no bearing on mortality. Contrary to what you might have heard, according to this study, being happy alone will not make you live any longer whatsoever. So you can grump to your heart's content, you might annoy people around you, but you won't be doing yourself any physiological harm either. This study does seem to fly in the face of a lot of recent findings on the links between a person's demeanor and their longevity, but according to Richard Peto, who is a co-author on the study and is a professor of medical statistics at Oxford, in our view, the previous studies haven't been well done. These previous studies didn't correct their population samples for people that already had diseases that they knew about, and they were in worse moods because of their ill health, and those people should have really been thrown out of the study. So what this study did is it looked at a large population sample. This study happened to be all women, but it only looked at women who were in good health, and then looked at their mood, their general level of happiness, and followed them for several years to see which ones survived. In other words, if they started the study period healthy, based on their mood, did they wind up dying of something during the course of the study period? Once the women who had pre-existing conditions that might have been dampening their mood were factored out of the study sample, all correlation between mortality and mood disappeared. So if you're feeling like Oscar the Grouch or Ebenezer Scrooge or any of those characters this Christmas season, know that you can at least do so in good health.
Smart Drug Smarts, the podcast so smart, we have smart in our title, twice.
Okay, you heard it. That is the entire episode at number 106. Thank you for hanging around until the very end. If you're still here, if you enjoyed what you heard, now is the part where I will warmly invite you to give absolutely no gifts this year except for Smart Drug Smarts tattoos. Anything you were thinking about giving away, just cancel those ideas. We'll put a downloadable image of a black and white version of the Smart Drug Smarts logo that you can take to your nearest tattoo parlor with your entire family, all the visiting family members from out of town, negotiate a package deal. Okay, you're probably not going to do that. But what you could do is you could tell some friends, those who you think might enjoy the podcast, just let them know that we exist, and that would be gift enough. Maybe not for them, but certainly for us. And in any event, we very much appreciate your listening, all jokes aside. The show notes for this episode will be online at smartdrugsmarts.com/106, including the links to everything that we talked about here. And I'll be back at you next Friday, same time, same podcast, and with the same unflagging commitment to helping you fine-tune the performance of your own brain. Have a great week until then. Stay warm and stay smart.
You've been listening to the Smart Drug Smarts podcast. Visit us online at www.smartdrugsmarts.com and subscribe to our mailing list to keep your neurons buzzing with the latest in brain optimization. Smart Drug Smarts should be listened to for entertainment purposes only, although some guests on the show are medical doctors, most are not, and the host is just some random guy. Nothing you hear on this podcast or read at smartdrugsmarts.com should be considered medical advice. Consult your doctor and use some damn common sense before doing anything you think might have a lasting impact on your brain.